So, like we talked from our previous video about thermal expansivity. Under thermal expansivity, we discussed about linear expansivity, and we are made to know that linear expansivity of a substance is the increase in length per unit length per degree rise in temperature. So, some problems were also listed for calculation, and I would like to address each of these problems one after the other. Now look at this example number one we have here. A brass rod is 2 meter long. Now recall from our formula, from linear expansivity formula, we have that linear expansivity is equals to change in length all of original length times change in temperature. So which is the same thing as L2 minus L1 all over L1 bracket change in temperature, or you can also say L2 minus L1 all over L1 bracket theta 2 minus theta 1. So each of these formulas can go for any related calculation. Now let's look at what we have. A brass rod is 2 meter long at a certain temperature. Now the brass rod, they say, is 2 meter long, meaning that the initial length of that brass rod is, which is L1, is 2 meters. That is the initial length of the brass rod. Now they also said that we should, what is its length for a temperature rise. Then when there is a variation in temperature, that means when heat is being applied to the rod must change length. So the second length is what we are trying to check, which we don't have. So we are going to check the second length, but the temperature changes, which is temperature changes is the temperature change is 100 Kelvin. So but linear expansivity is given as 18 times 10 raised to the power of minus 6 per Kelvin. So on this note, we are to check into what we are asked to and what is also obtainable. Now, by relating this to what we have here, by relating this, we say that linear expansivity is equals to L2 minus L1 all over L1 bracket change in temperature. This is what we have there. Therefore, you can see that our alpha here is what is given, which is linear expansivity, is given as 18 times 10 raised to the power of 6 minus 10 raised to the power of 6 is equals to L2 is not given, but our L1 is given. What is our L1? Our L1 is 2 meters. So put 2 over L1 also is 2 meters. You can see that our L1 is 2 meters, so we replace this with 2 bracket. Our theta, change in temperature, look at it here, is 100. So we apply 100 here. So what is the next? What is the next thing to do? The next thing is to do little calculations and try to, this time this is going to give us 200. So this is 200. What are we going to do again? We have to cross multiply this. We cross multiply. That means this times is 1 times this one. I just brought this one because I need to also have over something. This is over 1, but we are not putting the 1. Since we need to cross multiply for you to understand properly, I have to put this one so that we can cross multiply easily. So 1 times this will give us back this value. It's equals to 18 times 10 raised to the power of minus 6 times is 200. And this 200 is going to give us L2 minus 2 is equals to, so you use the calculator to get that. If you don't have calculator, sometimes, look, in JAM we don't use calculator, but let me just use calculator to get this value. So we have 18 times 10 raised to the power of minus 6 times 200 is giving us look at the value, 0.0036. So we have 0.0036. So what are we going to do now? We'll take like terms, collect like terms. So what I'm going to do now, say L2 is equals to, since we are collecting like these two, now we cross over to the other side, so it becomes plus. So you have this plus 2, because 2 is crossing over, it changes to plus. So L2 now is equals to 2.0036 meter. This is the new length. So this now, the change in length now becomes L2 minus L1, which is equals to 2.003 minus 2, which is the initial length, the first length. So it's going to give us 0.0036. So this is the difference in length. This is the increase when the heat was applied. So the length increased by 0.0036 meters. So that is that. Thank you very much.